Okay, some more problems from section 4.6, and these are cotangent, graphing these. And these aren't centered about 0 like our tangent, so it's a little trickier when we have some changes in the period, so we'll show you how to deal with those. You can't do it quite as intuitively as you can do the tangent. So this was basically number 17, y equals 2 cotangent of x. So we have kind of an amplitude type situation here. Otherwise, everything's the same. So we know from what we did in class, our experience, the asymptotes are just going to be at 0. Based upon our unit circle, we know that it's cotangent of 0 goes up to infinity, and then pi also. Because we have 0 in the denominator when we use our unit circle to find those cotangent issues. So those would be our normal asymptotes, and then this is our center. And remember, we talked about the fact that it's coming the opposite, and we check that out using these values. It's my halfway point between my center and my asymptote, so this would be pi over 4 again, and 3 pi over 4. And we found out that the cotangent of pi over 4 was 1, except now we're going to multiply it by 2, so that's going to make it 2, so it's going to be up here. And the cotangent of 3 pi over 4 was negative 1, except I multiply that by 2, so that's going to make it negative 2, so it's going to come down here. So basically that's what you've got. So you're going to be coming down like this. It's going to be a little bit flatter because of my scale. And then it's going to curve down around here and break towards that asymptote. So something like that. That's what happens when you use pins. Sorry about that. How we go through these points. And it's kind of flat. Then I want a 2 period, so I'll put another one. So remember, the normal period is pi, so another pi would make this from pi to 2 pi. So they can do a better job on this next sketch here. And then again, we got these points here. This is 2. I'm going to put my halfway point there. Between the center and the asymptotes, right between that 1 and negative 1, but in this case it would be 2. It's a little flatter because of mostly because of the scale in which I drew it. So something like that. So that would be your cotangent curve. Like I said, try to smooth this out. Okay, should have penciled it in, then kind of clean it up. Okay, and then number 19. There's a couple ways to do this, but this is a nifty way. We know that we have asymptotes at when the cotangent is 0 and at pi. So we could just set this equal to 0 to find out where the tangent is. And 2x equals 0 when x equals 0, so asymptotes. So we could set this equal to 0 to find out where the asymptotes are. Cotangent, when it's 0, we have an asymptote in the normal graph. And then when it's pi, so I can just set 2x equal to pi, and that's going to be pi over 2 for this situation. And remember, my period is going to be what am I doing? My period is pi over 2, pi over b, which is pi over 2. So that's going to be my period. So I'm going to use the same scale so you can kind of see what's happening here. So if this would be pi over 2, and this would be pi over 4, I know I have asymptotes in this case now at 0 and pi over 2 because of this 2 over here. Changes my period. So I'll put my asymptotes here at 0. X equals 0. which is the same thing as the parent function of the main function, but now because of this 2 here, it's reduced the period from pi to pi over 2 because I divide by 2. And you can also see where the asymptotes are going to be at 0 and pi over 2. So they kind of reinforce each other. So if that's going to be straight, I can't see my other ones with my thickness of my ruler, but hopefully this will be all right. Okay, there we go. Not too bad. So my center point here is now pi over 2. And remember, we still have the asymptote at 0, but the other one's at pi over 2. It's moved over a little bit. And then if this is pi over 4, in order to get this into scale, remember pi over 2 is about 1.5. Was the same scale, so that'll make this 1 and this 2. Negative 1 and negative 2. But I've got 1/2, so we can check this out if we take this as our center point. And remember, in order to find our checkpoints, we go right between the center point, and the asymptote. So if this is pi over 4, this would be pi over 8. So let's put pi over 8 into the equation, see what we get. What's 2 times pi over 8? Pi over 4. What's a cotangent of pi over 4? 1. That's positive 1, just like the tangent of pi over 4. But then I take 1/2 of that, and we get this. And then this one over here would be 3 pi over 8. And if I multiply 3 pi over 8 by 2, I get 3 pi over 4, and the cotangent of 3 pi over 4 is negative 1, but if I multiply that times 1/2, I get negative 1/2, and that's over here. So that's right there. So I hope you can see those 3 checkpoints there. I can put them in green. Maybe that'll be a little bit better color for now. Put that in green. So those are my 3 points, and so I know it's going to look like this. This will be a little bit easier to draw because of this. It's a little steeper. Oops, just when I spoke I messed up. So there you go. And then we wanted to do 2 periods of this. So if this is pi over 2, then this would be pi. So that would be the other one, pi. Because the period's pi over 2, and this would be my center point. So I'll draw my other asymptotes. Hopefully we'll be in business here. And then same idea, put our points in. And we can just kind of parallel this. We'll put our in between the center and the asymptotes will be your checkpoints. In this case, it'd be the 1/2 goes here, and the negative 1/2 goes there. And again, we can sketch it. Goes over through like that. Then it starts to shift the other way as far as concavity is concerned. And we go down like that. And that looks a little bit niftier than the first one because it's not so steep, so you can see the bends a little bit better. Okay, so that's number 19. Okay, so that kind of makes sense. See how we work that out. Once you find the asymptotes, then you're in business. So you got the center. Once you have the 2 asymptotes, then the center is just right in the middle, and then again you divide it up into 1, 2, 3, 4 little subintervals. Very similar to we do the sine and cosine. We divide those up into 4 subintervals. The same idea to get your key points for your tangent and cotangent. You can see 4 subintervals. 1, 2, 3, 4. The only thing is that the endpoints aren't 1s or 0s, they're asymptotes. Okay? Hope that helps.